How are you, grade 10 learners? Were you able to solve polynomial equation using remainder theorem? How about synthetic division method? Very good. This time, I will present to you another way of solving polynomial equation. Let me present to you my screen. Hello, grade 10 learners. We are now in part 3 of polynomial equation. We will apply rational root theorem in solving polynomial equation this time. Example, solve 3x raised to 4 minus 16x cubed plus 21x squared minus 6x minus 12 equals 0. For step 1, we will find p. P are factors of negative 12. Negative 12 is the constant or last term of the given polynomial equation. We will also find q. Q are the factors of 3, the leading coefficient in our given polynomial equation. Step 2, we will do synthetic or apply the remainder theorem. Still, we can also apply the trial and error method. So trial 1, have the possible rational root, which is p over q, or p divided by q. This time, we will use negative 2 as our p. Negative 2 is a factor of negative 12 because negative 2 times 6 is negative 12. Over 3, for our q, 3 is a factor of 3, our first numerical coefficient, because 3 times 1 equals 3. So our p over q here will serve as our r, which is negative 2 over 3. So in synthetic division method, we will copy the numerical coefficients of the polynomial equation. Don't forget to arrange the exponent from highest to lowest. And then 3 will be our first numerical coefficient because 3, x raised to 4, has the highest exponent. This is the leading term. Followed by negative 16, then 21, negative 6, and then negative 12. Copy 3, the first numerical coefficient on the third row. 3 times negative 2 divided by 3 will give us negative 2. Combine negative 16 and negative 2, the answer is negative 18. Negative 18 multiplied by negative 2 and then divide by 3, the answer is negative 12. Combined with 21, so 21 combined with negative 12 is positive 9. Positive 9 times negative 2 divided by 3 will give us negative 6. Negative 6 combined with negative 6 is negative 12. Negative 12 multiplied with negative 2 divided by 3 will give us positive 12. Negative 12 combined with positive 12 will give us 0. The remainder is 0. Therefore, negative 2 over 3 is a root of 3x raised to 4 minus 16x cubed plus 21x squared minus 6x minus 12 equals 0. For trial number 2, we will use negative 4 as our p and 3 as our q. Negative 4 is a factor of negative 12 because negative 4 times 3 is negative 12. And again, 3 is a factor of our leading coefficient, which is 3. So, in solving polynomial equation, applying rational root theorem, to find all the possible rational roots, we will find p over q. In this example, 3x raised to 4 minus 16x cubed plus 21x squared minus 6x minus 12 equals 0. Our factors of negative 12, the last term, which is represented by p, are negative 12 and 1 because negative 12 times 1 equals negative 12. 12 and negative 1 because 12 times negative 1 is negative 12. 6 and negative 2 because 6 times negative 2 is negative 12. Negative 6 and 2, negative 4 and 3, 4 and negative 3. For q, which are the factors of 3, the leading coefficient, we have 3 times 1, or 3 and 1 is 3, negative 3 and negative 1, which is also positive 3. So if we will form our p over q using negative 12 as our p, we have negative 12 over 3, negative 12 over negative 3, negative 12 over 1, negative 12 over negative 1, which can be simplified into negative 4. We have negative 12 over 3 is negative 4. We have negative 12 over negative 3 is positive 4. Negative 12 over 1 is negative 12. Negative 12 over negative 1 is positive 12. 12 over 3 is positive 4. The same as negative 12 over negative 3 is also positive 4. Positive 12 over negative 3 is negative 4, like negative 12 over positive 3. 12 over 1 is positive 12, like negative 12 over negative 1. 12 over negative 1 is negative 12, which is also equal to negative 12 over 1 is negative 12. If our P is 1, we have 1 over 3, 1 over negative 3, 1 over 1, 1 over negative 1, negative 1 over 3, negative 1 over negative 3, negative 1 over 1, negative 1 over negative 1. Our P can also be 4 or negative 4. It can be 2. 2 over 3, 2 over negative 3, 2 over 1, 2 over negative 1, negative 2 over 3, negative 2 over negative 3, negative 2 over 1, negative 2 over negative 1. We can also use 6 as our P. We can use negative 6, we can use positive 3, and we can use negative 3. So if our P is 6, we have 6 over 3, 6 over negative 3, 6 over 1, 6 over negative 1, which can be simplified into 6 over 3 is 2. 6 over negative 3 is negative 2. So all in all, we have, in simplest form, P over Q can be positive negative 12, positive negative 4, positive negative 2, positive negative 1/3, positive negative 1, positive negative 4/3, positive negative 4, positive negative 3, positive negative 2/3, and positive negative 2. So again, in 3x raised to 4 minus 16x cubed plus 21x squared minus 6x minus 12 equals 0, the possible value of P over Q in simplest form are positive negative 12, positive negative 4, positive negative 2, positive negative 1/3, positive negative 1, positive negative 4/3, positive negative 3, and positive negative 2/3. These are the values of R that we can use when we do synthetic division method. We can also use this, substitute for the value of x if we will use the remainder theorem. Now, based on our example, one of the rational root of 3x raised to 4 minus 16x cubed plus 21x squared minus 6x minus 12 equals 0 is x equals negative 2/3 because the remainder is 0 when we do synthetic division method and use P over Q equals negative 2/3. Your assignment is find the other roots using synthetic or remainder theorem using the list of possible rational roots P over Q in simplest form. Happy learning. Stay safe, happy learning, healthy, pray always.